Góðan daginn og verið hjertalega velkomin til Johan Rönning. Mjög ánægilegt að sjá hversu vel þessi fyrirlestur sóttur. Það greinilega mikill áhugi fyrir rafbílum og hraðhleðslutækjum sem að verða kynnt fyrir ykkur hérna í dag, svona út frá ýmsum vinklum, bæði tækin sjálf, rekstur kerfana og svona almenn kynning á því sem að ABB hefur fram að færa. Við höfum fengið til okkar tvo sérfræðinga á þessu sviði. Þetta eru svona svolítið skipt upp í tvennt. Við byrjum með Stephen Josten frá ABB í Hollandi. Hann mun hefja kynninguna og eftir svona klukkutíma þá er ekki hlé, tíminn eftir að byrja og á eftir honum kemur fyrirlesari frá ABB í Danmörku, Johan Rönning, sem að heldur svona tekur við keflinu þar sem frá var horfið. Hikið ekki við að spyrja ef þið hafið spurningar, þannig að þetta verður svona svolítið lifandi samræður hérna á milli ykkar og hérna Stephen. Stephen, what is yours?
Thank you very much. So my name is Stephen Rönning. I'm responsible for Europe within our product group, EV charging infrastructure. And today I would like to take you a little bit through our products. First I will talk a little bit about the background, the strategy and some reference projects which we have. Then how we work as ABB together with the car manufacturers, because this is of extremely big importance for us, because chargers have to work with the cars, so working with the car manufacturers is of our biggest importance. Then I'll talk a little bit about which cars are on the market now, which charging standards do they have, and which cars are going to come in the near future. Then a little bit about our fast chargers, about the connected services. These are the connections to the back office systems. Okay, let's continue. So a little bit about connected services, that is the software part around it, how we connect to back office systems and other solutions. And then at the end, well, why should you choose ABB and why not somebody else? I prefer very much to have an open dialogue with you. So I prefer not that I just present and that at the end you put the questions, but if you have questions, please put them to me, because I prefer that we interact and that you put your questions when you want. But yeah, please, if you want to know about connected to the back offices, don't put this question here, because as you can see, we will come to that later. A little bit about why are we ABB so interested in electric vehicles and electric charging? Well, very simply, because if you look to a lot of alternative fuels which are on the market, like biofuels or like hydrogen, simply if you use the range you can achieve per square meter of land, electric cars are the most efficient in that. And if you look to a market transportation system like an electric car, if you look like a mass market transportation system like an electric car, of course the efficiency, the well-to-wheel efficiency as we call it, is very important, because you don't want that a mass transportation system would be very inefficient. That would be a pity, because then as a humankind we are throwing a lot of energy around and not using it efficiently. In Europe we talk a lot about e-mobility and pollution of the air, but this is a slide I take from Mr. Wangan. He made a presentation in May 2013 in Berlin. We were invited by Angela Merkel and her government to talk about e-mobility. And this is a slide of the Minister Wangan from China, and he tells us that if you look to the pollution in the major cities in China, the pollution is so bad that it's not about a luxury thing anymore to talk about electric vehicles, because it's either do or die in China. There is no other way. One of our colleagues now, China is a very important market also for ABB. One of my colleagues, Jeroen, is in Shenzhen, and Shenzhen is in fact one of the better cities in China. But when he takes his little daughter for a walk, they go walking in the shopping mall and not outside. And the little girl asks, Daddy, must we put on a protection for the air today, yes or no, if we go outside? So this is China. But don't think that, one small remark. In China, my previous boss, Hans, came to China in, I think it was around 2 years ago, in Shenzhen. And he saw an island with 12 fast charging stations. And Hans said, wow, this is a market, we have to be here, because we can sell a lot of fast charging stations. And he asked a Chinese guy, because we never saw at that time 12 fast charging stations so close by next to each other. So he said to this Chinese guy, he said, are you going to make more? The Chinese guy said, yes, we are going to make more. So Hans came back 1 year later to the same spot, and he's seeing this small island on the street with the 12 fast charging stations. So Hans was very disappointed because he thought that it would be much more. So he said to another Chinese guy, he said, what happened? Because last year a guy told me that there will be much more stations. And then the guy said, yes, please come. And took him off the cellar of a high-riser building. And here in the cellar are 137 fast chargers, each 90 kilowatts. And there is a 5 megawatt connection to the grid going into this building for all the electric taxis. So at the moment it's empty because the cars are driving, but during lunch break, all the cars come in and every taxi knows exactly where it has to stand to fast charge. So this is China. So be aware, I'm very sure that we will see Chinese cars, Indian cars coming to Europe in the next 10 years. Companies like Mahindra, GD in China, Mahindra India, have already announced that they will start making research and development facilities in Europe for electric cars. Okay. Don't think that smog and pollution is only something for China. Also in Europe, in Paris, this was 2014, only half of the cars were allowed to drive because there was so much pollution. And if you have read the newspapers, that also in some countries, I think also in Paris now, they have said that on bad days, diesel cars are not allowed to drive anymore in the cities. So you see a lot of problems also in Europe about smoke in the cities. In London, officially, if you live inside London, you live 4 years shorter than if you live outside London. And these are official numbers of the British government. So they are not secret numbers, they are not things they are hiding. This is just what smoke and small particles in the air can do to you. A little bit about ABB. I was working at a small company called Appium, and we were making fast charges and some software stuff. And we were bought by ABB about 4 years ago, because ABB thought that we were making interesting stuff and they would like to have it. But ABB also acquired a lot of other companies, like New Wave in power quality, Ventix in grid automation, Power One, they make solar inverters. They are the second largest solar inverter maker in the world. And what you will see in the coming years is that all those things will be connected with software to each other, and they will work together. Smart chargers, fast chargers, together with smart grid solutions for the home. Fast charging combined with solar inverters, building automation together with home charging, also power quality and fast charging for buses, because at the moment I will not talk about it in the rest of my presentation, but as ABB we also have a cooperation, for example, with Volvo Bus, to work on fast charging of electric buses. And then power quality is of extreme importance. Where are we buried today? We have sold one fast charging system in 2010. That was May 2010. In the meantime, we have sold over 2,000 systems throughout the world. And you can see the countries here where we are selling. And at the beginning, it was, of course, China, it was America, it was the western part of Europe. But now also you can see countries like Romania, India, Sri Lanka, also they are buying fast charging stations. Which is good, because now you see that many countries are really working on cleanliness of the air. This is just a small list of projects which we had recently in the last coming months. I know that my colleague Jonas from Denmark, he will talk more about Eon and Clever, but also in Sweden and Norway, Germany. We have also here in America with some car manufacturers. I will also talk about how we cooperate with the European car manufacturers. So many projects over the whole world. Important for us was last year, where we also launched, as you probably know, in Europe we have a couple of standards. We have the SAA Combo standard, CCS standard. We have CHAdeMO, and we also have AC charging. I will come back to that later in my presentation. But in China, they have their own standard, the so-called GB standard. And for us, it was very important this moment last year, where we also launched the first fast charger with the Chinese standard. Because that means that we as a company, we are the only company in the world who can produce all the standards over the whole world. China, as I said, is going very fast. We have a project with Denza. Denza is the joint venture between BYD, Build Your Dreams, it's a Chinese car manufacturer, together with Daimler. Daimler is the car manufacturer of Mercedes-Benz and Smart. And they have this joint venture in China called Denza. And Denza has an electric car here, which has a range roughly of 300 kilometers. And we are making a DC wallbox for this car. So, in which the people can charge the car at home with 10 or 20 kilowatts DC fast charging. And this box is sold together with the car at the dealers. Another big project for us is Estonia. This is the first largest project in Europe. It was opened in February 2013, so it's already running for more than 2 years, where we have around 200 fast charging stations, like this one, over the whole country. And for that time, we had all the payment systems which are possible, like a membership model with a RFID card, or SMS payment, or a smartphone app payment, or even payment via web. E-wallet payments, all this kind of stuff is already on this already for more than 2 years. We have learned a lot from this project, because also like Iceland, the temperatures in Estonia are quite low. So we have learned a lot about how do chargers behave in snow at minus 20 or minus 30 degrees, all this kind of stuff. Another important customer for us is Nissan. Nissan makes their own fast chargers. You probably know Nissan DBT. But in the factories and in their development department, they use ABB fast chargers at the end of the production lines to charge all the Nissan Leafs, which comes from their production lines in Sunderland in the UK, and in Barcelona, where they make this little bus, the ENV 200. The reason why they use ABB fast chargers is because of their reliability. These are pictures which were in the newspaper, so therefore I can share them with you. Because normally you're not allowed to make pictures of production lines of cars. Clever, Jonas will explain more about this. I will not speak too much about it. At Clever we have a huge network of fast chargers already throughout the whole of Denmark. Another important customer for us is Fastnet in Holland. Fastnet acquired 201 of the 243 locations along the highways where you can charge electric cars. So there was a tender, and Fastnet won 201 of the 243 locations. On each location, they will put 2 to 4 fast chargers. And now they are building this fast charging network. They have a clear idea how they're going to build. They have now, I think, around 28, 29 stations open. So in totally they have around 90 fast chargers, and they are growing with 1 per week. That fast charging is happening in Europe. This is if you look to the Shademo website, you can find this map of Europe, and you can see already that there are, this is situation of probably 2 weeks ago, around 1,650 fast chargers of Shademo in Europe. CCS, that is the competing system from the German and the American car manufacturers. They only started a little bit less than 1.5 years ago. They are already on 843. And now you cannot add this number together with this number, because all the fast chargers we are selling now, in fact, are dual or triple output systems. We are not selling any more Shademo only fast chargers or CCS only fast chargers. The systems we are selling have both systems in them. But you see that CCS is picking up very fast. As I said in the beginning, it is very important for us to work with the car manufacturers. And as ABB, we work very closely with a lot of them. In BMW, we work as an R&D partner with them. But we were also asked to supply all their dealers and all their own buildings in Europe and the USA with fast chargers from us. With Volkswagen, we are R&D partner, and we were also asked to supply all the fast chargers for all the dealers throughout Europe. With Porsche, we are R&D partners, and we also made a DC wallbox for this car, the Porsche 918. Somebody knows this car? No? This is a car for the happy few, I'm afraid. The price is 800,000 euros. It's a hybrid, in fact. It's a plug-in hybrid. They only use the electric cars for power. So it goes from 0 to 100 in 2.8 seconds. It's like a totally racing car. And you can get a special package on this car where they reduce all the weight with 40 kilograms. And then you pay another 30 or 40,000 euros. And one of the ways to reduce the weight is, for example, not to paint the car, but to put, foil on the car. Because by just putting the foil and taking the paint off, you can reduce another 4 kilograms. So, yeah, this is not a normal car. And it's a pity for you, because they have been sold all, so you cannot buy them anymore. Because it's the Porsche 918, and there is 918 made of them and sold. So you cannot buy it anymore. With Audi, we are R&D partners. Audi so far does not have a full electric car on the market yet. Toyota, we are also supplying, for example, to Toyota in Japan, R&D. Same for Honda. This I talked already about. This is the cooperation we have with BYD Denza. We are R&D partner, and we make the DC wallbox for them. Nissan Dongfeng, this is also a cooperation in China. We are also R&D partners, and we make the DC fast chargers for the dealers. In GM, In America, we work together with them on testing and R&D. Ford, the same in America. And for Kia in the US, we are working with them for the dealers at the moment. So by this, we can also ensure in our close cooperations with the car manufacturers that really all the cars are tested before they come to market. Any questions so far? Because if you have a question, just raise your finger and put your question. Combo, CCS standard. This is the standard which is made by the German car manufacturers together with the Americans. So BMW, Daimler, GM, Volkswagen, Ford, Audi and Porsche decided not to go for the CHAdeMO standard, but to make an own standard, the so-called combined charging system, CCS or SAE, CCS system. We have been working already a long time with them, and already on May 2012, we showed the first prototype which can work together with a BMW car in Los Angeles. This cooperation with the German car manufacturers went further. In Berlin, May 2013, we were asked by Volkswagen to put our charger in front of the stage where Angela Merkel was there. This was the famous presentation where also Mr. Wang Gang from China made this presentation about the air pollution in China. And our charger was shown together with the Volkswagen ear of the Golf of Volkswagen. This cooperation with BMW and Volkswagen continued. In June, July 2013, in June, Volkswagen opened the first charging station in Wolfsburg, where they have their headquarters. And exactly 2 or 3 weeks later, BMW opened their fast charging station, their first public fast charging station, with the BMW i3, it's still here in camouflage, at the BMW World in Munich. That we were asked by Volkswagen to put our chargers at their dealers. So these are some examples of Hamach. This is Switzerland, this is Volkswagen, and the same for BMW. As you can see here, BMW has 2 colors. The white color, which they use for their own buildings, and the blue colors, which they use for their dealers. And also this is an example of Switzerland. This is the Porsche wallbox which we make. This is a 20 kilowatt DC wallbox for people at home. It's in production already since some time, but we were a long time not allowed to speak about this because we had a non-disclosure agreement with Porsche, and only 1 year after production we were allowed to speak about it. So this is the famous Porsche 918, the car of 800,000 euros. Kia, this is Kia USA. So, as I already said before, ABB were selected to provide fast chargers for all the dealers in the US who will make the Kia Soul. The Kia Soul is a small electric car with a good price and has quite a big battery for such a small car, 27 kilowatt hour, and can also drive very fast if you don't very low, if you don't drive too fast, because the aerodynamics of this car are, let's say, not very smooth. So it is a car really as a city car and not to drive on highways with a long distance. I don't know how many of you are really involved in fast charging. Normally, if you charge a car at home at AC, you have an onboard charger which converts the AC of your socket at home or your AC wallbox at home into DC, because the battery of a car is DC and you need an onboard converter. Many car manufacturers don't want to make this onboard converter very big, because to put this kind of system in your car means that you will add weight to the car. Weight means less range. You add extra cost to the car, which makes the car more expensive. And it costs space. And in a car, there's always a fight about space, because you want to have as much as possible space either for the passengers or for the luggage you take with you. So you will see many cars who have onboard chargers, let's say 3.6 to 7.2 kilowatts. Some cars will have bigger, I will come back later on that. But many car manufacturers would like to have this as small as possible, and preferably in the future to leave this maybe totally away. Because many car manufacturers think that when there is enough DC infrastructure in the world, because with, like say, a DC fast charger, like the products we are talking about today, we go directly to the battery. There is no converter anymore in the car. And the only reason that this is in the car is that you can do emergency charging at home or whatever, or slow charging at home. But if also at home you would have a DC charger, but a smaller one, if that one would be of a good price, you could leave away this total onboard charger. And this is what many car manufacturers want to reach maybe in 10 or 15 years. Take this totally out of the car. The good thing is, if you put it, of course, if you put this converters, in fact, in the charger, then all these investments you can share with many hundreds of other users. Many people put the question, yeah, but is fast charging, is it good for the battery or does it damage the battery? The answer is very simple. Fortunately, the car manufacturers make it very simple for me. If you buy a Tesla, if you buy a Nissan Leaf, if you buy a Volkswagen Golf or a Volkswagen E or a BMW i3, you get 8 years warranty on the battery, even if you fast charge. This means that the batteries which are in the actual cars nowadays, they are made to be fast charged. They are built to be fast charged. So a car manufacturer will not give you 8-year warranty when he knows that after 8.5 years the battery will break down. So for sure you can say that these kind of batteries will last maybe 12 or 15 years or whatever. So there is no worry about the battery. Another thing I would like to stress is that why can car manufacturers make a guarantee on the battery? Also that is very simple, because the battery management system, which is here drawn on top of the battery, communicates to the fast charger how much power the fast charger can give. So the BMS, the battery management system, is the master, and in fact the charger is the slave. So the curve which we can make go up in power and then for some time on full power and then go down is totally dictated by this battery management system. And because the battery management system and thus the car manufacturer is in charge of the charging cycles, therefore they can also give this guarantee. Because if they would not be in charge of all the fast charging cycles, how can they give a warranty? But they can do this because they are in charge. And when we as a charger manufacturer, if our chargers don't follow the curve which this battery management system is giving us, then the car will stop the charging and will say, okay, you're not doing what I want, and I will stop the charging because you're damaging my battery. And we have to follow the number of amps within a very small bandwidth. So, as I said, the good thing is that the actual cars on the market are really of a very, very good quality. This is a complex slide. I will take you through it, but perhaps it is one of the most important slides of my presentation. Because as a fast charger manufacturer, what we say is we follow the car. Because we don't determine which standard we are going to take. The car manufacturers determine this, and we as a charger manufacturer, we have to follow the market. So all those cars which you can see here can all be slow charged on, let's say, 3.6 to maybe 7.2 kilowatts. But the first cars which came on the market, there were some cars in front of here, the Norwegian Think, I Maybe you remember the Norwegian Think car. It was built in Norway. All the first cars which came on the market could only be slow charged. So the problem with such a car was that very nice that you can charge at home, but once you got stuck somewhere and you were out of range, then you had to stand maybe for 4 or 5 hours to fill your car again and to be able to drive a reasonable distance. The good thing is that this all was changed in October 2010 when the first Mitsubishi EMS came to Europe. For the first time we got a car in Europe which was mass produced and which could be charged by the CHAdeMO standard. And in fact the Mitsubishi cannot be charged by 50 kilowatts. I think it goes maximum to something like 43 kilowatts. And for the first time there was a car on the market which could really be fast charged. And you could charge, if your battery was almost empty, you could charge in 15 to 20 minutes. You could charge again and then you could drive another roughly 100 kilometers. A little bit later the Nissan Leaf came. This came from Japan. And Mitsubishi also made 2 cars, the Peugeot Eon and the Citroën C0. They are all made in the same factory in Japan. And later they made the Peugeot partner, the Citroën Berlingo. This is a strange car. This is a Mitsubishi Outlander, the plug-in hybrid. This is, so far as I know, the only plug-in hybrid which can be fast charged by CHAdeMO. Later came the Nissan Leaf 1.1. This is the one which is made in Europe, in the Sunderland factory in the UK. The Nissan ENV 200, this little bus which is built in Barcelona. And one of the most recent cars is the Kia Soul, with CHAdeMO. In the meantime, you have also some car makers who are working on AC charging. They did not make the step to DC charging. You have the Smart. It started off with only fast charge, with only slow charge. Then they made as an option where you could go to 22 kilowatt AC. Renault Zoe even made a car, Renault made a car, the Zoe, which could charge up to 43 kilowatt AC. But the next generation of Zoe can only be charged by 22 kilowatt AC. Or, for some people who still want to be 43 kilowatt, they will use the old inverter, which is in this car, also in a new car. But they will not make a new development for a new inverter. And strangely enough, Mercedes-Benz Daimler comes with the car, the Mercedes B-Class. This basically has Tesla technology on board, which can be charged by 11 kilowatt AC. So these are the only cars which can be charged AC, which is only Daimler and Renault. Tesla is also here because Tesla, as you know, has their own fast charging standard, but you can also charge a Tesla with 22 kilowatt AC. And nowadays, in a lot of countries, they have rolled out their CHAdeMO adapter. And with the CHAdeMO adapter, you can also charge a Tesla at the CHAdeMO fast charging station. The Germans were very late in this whole story. Around 3 years after Mitsubishi came to Europe, BMW and Volkswagen came with their cars, the Volkswagen eR and the BMW i3. And as I said before, they did not go for a CHAdeMO standard. They wanted to have an own standard on political and also on technical reasons. And they choose for the CCS standard or the combo standard. As I showed on the other picture, you see now the fast charges for those cars already growing very fast. The good thing is that if you look a little bit to what is announced in the market, you will see that a lot of new cars are coming here. The Audi R8 e-tron, that's a small quantity, but with a very big battery. The biggest battery of the Tesla is 85 kilowatt hours, but this Audi R8 e-tron will have a 92 kilowatt hour battery. The Chevrolet Bolt, 300 kilometer range. Volkswagen e-Golf, 300 kilometer range. So what you see is that the problem of, in fact, cars we have here today is that they are quite expensive and the range is very limited, quite limited. So these are, let's say, more city cars, except the Tesla, but the Tesla is a more luxury car. You will see here that in this period, a lot of cars will come all with ranges of 300 kilometers and up. Porsche will come with a 100% EV. Audi will come, they will make Tesla killers. They are, so these are really cars who are going to fight against Tesla. And also, in the meantime, Jaguar Land Rover, GLR, has told that they will come with a 100% electric car. Hyundai will come with an EV. They have not announced which standard they will make, CCS or Shademo, but we think that we know with which standard they will come. And also, for example, if you look into the magazines, you will already see much more rumors about new cars coming here. Also, those cars with bigger batteries. So you can really see that e-mobility is becoming very mature. So in the beginning, we had cars which were toys, like the Thing, very nice, but high price and quality not good. In the meantime, we have a huge bunch of cars where the quality is really good, where batteries have an 8-year warranty. But the problem of the cars of today is that they are quite expensive and the range is limited. So they cannot be used for everybody. But the good thing is that if you look at this time frame, a lot of this will change. And the reason that they will come is because of the dropping of the battery price. The battery price is going very fast down. Battery prices were first something like 1,000 euros per kilowatt hour. Prices are now maybe around 200 euros per kilowatt hour, 250. And for example, Mr. Craves, he is a high-level executive in Volkswagen. He said, once the prices have gone down to below 100 euros per kilowatt hour, then making an EV is cheaper than making a car with a gasoline or a diesel engine. So, and this point is not so very far away. So we believe that e-mobility is there, will stay there, and will continue as it goes. And it is sometimes a little bit frustrating, just like in the beginning, like we had the digital cameras, the first digital cameras which came on the market. They were expensive, only very few megapixels, and the quality was by far not as good as the analog cameras. But nowadays, I think nobody of you is using an analog camera anymore. And all of us are using digital cameras, and we are using our smartphones to make pictures, because the analog camera, only for a small group of enthusiasts, is dead. And we believe that that this will also happening with the automobiles. But you must not forget, going from a car with a combustion engine to an electric car is for a car maker a huge change. Many things will happen there. In factories, they don't need to make this beautiful gasoline engines, gas engines anymore, or diesel engines. And also in the whole maintenance of electric cars, a lot of things will change. As I said, today we have cars roughly with a driving range of 120 to 140 kilometers. Price ranges around this. And why? Because batteries are 24 kilowatt an hour, typically those type of cars. The Tesla is a different animal, driving range of 400 kilometers, DC fast charge, 300 kilometers in 30 minutes, but a different price tag. And why? Because the battery is simply much bigger. In China, you already see a car, the one which we are making, the DC wallbox, which has a 300 kilometer drive range and And why? Because it has a 48 kilowatt battery. And this is exactly what you're also going to see happening in Europe. You will see cars in the middle segments coming also with larger batteries. I spoke about the CHAdeMO adapter of the Tesla. I don't know if you have seen one. This is one. You can buy it now at the Tesla webshop in many countries. I don't know if it's already available here in Iceland, but for roughly...
It is.
It is, yeah. So roughly, I think something like 500 euros, something like there, should be the price for this adapter. And then here the connector of the car, you can hang it down. And this is the Yazaki connector of a CHAdeMO station. We have tested this testing. We know that our chargers work with the system. But of course, if Tesla changes something to that, then we must test again. But we know that all our chargers work with the actual systems.
Excuse me. You mentioned that the difference between the CCS connectors and the CHAdeMO connectors was mostly political. But are there any technical differences?
I said technical and political. Yes, there are technical differences because CHAdeMO works with a CAN bus. Combo works with power line communication, for example. And one of the ideas is that explaining something. I don't know if you know, the CCS standard which we have per today. There was an ISO working group working on the CCS standard. But the ISO working group was not coming fast enough to the conclusion. And the Germans knew that they wanted to launch, in this date, they wanted to launch a car. Because in a car maker, you cannot shift a launch date of a car. You lose millions and millions with it. So the launch date of a car is something which is very hard in stone. So, in fact, what they did is, although the ISO standard was still discussing, the Germans at a certain moment decided to say, okay, we cannot wait any longer. We will make a DIN standard. So instead of the ISO standard, they froze a part of the standard and made it into a DIN standard, Deutsche Industrienorm, and all the cars which you can see here, and also all our charges are based on this DIN norm. And later, somewhere maybe here, God knows when this will happen, but somewhere here, you will. The cars have to be upgraded to this ISO standard, and also the chargers have to be upgraded to this ISO standard. This will happen somewhere. This is a software update. The good thing is for people who buy ABB chargers, all our chargers can be updated remotely. So we can, from our development facilities in Holland, we can update all the chargers over the whole bit. If they are in China or in the North Pole or where they are, we can update them remotely. If you buy another charger from another car manufacturer, you probably will have to go there with a memory stick with a USB stick to update it because it cannot be done remotely. Was a correct question. Huh? So there is technical differences between the two. One of the other things was that the Germans, they wanted to have one hole in the car. Because if you look to, for example, the Mitsubishi EMF, you will see that on one side at the back there is the fast charging plug, and on the other side is the slow charging. And the Germans said we want one hole in the car, just like a gasoline car. We want to have the AC and the DC fast charging in the same spot. And that is also why it is called combined charging system, because it combines AC and DC. But I can also tell you there is also a political one. And that is logical, because the Germans and the Americans don't want to be dependent on a Japanese standard. And that is also why, for example, in China, they don't want to have a CHAdeMO standard. They basically copied the CHAdeMO standard and made their own GB standard out of it. But they don't want CHAdeMO, and they don't want Combo in China. They want to have their own standard because they can politically influence it. So, yes, there are political and there are also technical reasons.
The Chinese standard stations, will available in Europe or?
They are not readily available. We sell them to some customers who where we have special relationships with. Why do you ask?
Yeah, we have BYD E6 here, so.
But can the BYD be charged by GB standard or is it AC?
AC.
AC, yeah, that makes sense.
Yeah, but they can send a lot of energy inside, but we don't have any stations to supply them with that.
Yeah, but the GB standard is also DC standard.
Oh.
And BYD is on AC, that's
Yes.
correct. But hopefully they will also make the switch to DC. Because in that sense, they are very modern in one sense. In the other sense, it's a little bit strange that they have not yet made the step to DC.
When will the ISO standard be ready?
I think they have standardized it. I think the standardization is at the end. But when it will be implemented in the cars, I don't know yet. But it will come. One of the things you can do, if you have a full ISO implementation, the car can identify itself, and you can use this also for payment systems. But there are many other things you can do. But for us, it depends on the car manufacturers. Only when they put this in the cars, we can put this in the chargers. As long as they don't put it in the cars, there's no sense for us to put it in the charger.
ISO is international. Do you think it's likely that all the world will follow it around Chinese or?
No. No. So this is, as I said, this is political stuff. Maybe in 10 years, 15 years from now, you will see things, but whole Japan, I think there are 5,000 fast chargers in Japan, almost Shalimon. Yeah. So maybe in a long time from now, but at the moment not. At the moment the groups are still not cooperating in that sense. But for us it makes no difference because we have chargers which can do all three standards, so we don't care.
You think there will be a adapter for those systems?
Yeah, well, Tesla has an adapter, but in some countries adapters are not allowed, this high power. We also believe that maybe one day Tesla has to make up their decision, because you know that in Europe the decision is made that CCS standard will be the prevailing standard, and you are allowed to have a second standard next to that, but all fast chargers which are put in the market, I think somewhere from 2017 onwards, must have CCS and can have a second standard, but must have CCS. So if you are smart, if you're a car maker, then one day you will start making a car with a CCS standard, because this for sure will stay in Europe. A little bit about the standard. So most of the companies which I showed you on the picture, they have AC charging at home. As I said, most of them have between 3.6 and 7.2 kilowatts. So this you use at home, but if you're on the road and if you need to charge your car fast, then you do DC fast charge. So Nissan, Mitsubishi, Volkswagen, and all the other guys which are here support this. Only two guys, which I showed on this famous car slide, do it different. That's Renault and Daimler. Daimler is Mercedes-Benz and Smart. Daimler already said that one day they will shift there. They will go to DC fast charging once there is enough infrastructure. And Renault has not made an official announcement yet, but yeah, you can already see that Renault is not developing a new 43 kilowatt AC charger in the car. So I would not be surprised, let me put it like that, that also Renault in the future will move here. That is my expectation. And maybe in 2 years' time or 1 year, 2 years, we will see each other again, and then let's see if I was right. Which companies are behind the standards? So CCS standard Audi, BMW, Daimler, Ford, Kia, Porsche, Volkswagen, I explained to you. Shademo in Europe is mainly pushed by Nissan and Mitsubishi, and especially Nissan. And the AC standard is pushed by Daimler and Renault. So, and Daimler already mentioned that they will go here. So, yeah, you can make your own guess, but I would guess that on the longer term in Europe, if nothing goes strange, then I would expect that CCS will be the prevailing standard on the longer term.
And China has a copy of the Shadowmere.
Yeah, China has a copy of this of the Shadowmere, but they made some things different. And one of the things we found out when we were testing together with Denza, that there are some problems in the Chinese standard. So, in fact, the Chinese standard is a GB, so GB and then /T from temporary, because the Chinese standard is not yet fixed. So we are discussing, we have given our ideas to the Chinese Standardization Committee and said, okay, we believe that standard is good, but we believe that you need to make some, let's say, minor modifications to really make it totally safe and this kind of things. Because in the, you remember one of the first slides I showed you, there's all the fast chargers in the cellar of the big building there. Those chargers, you can, while the car is charging, you can take out the plug and you can see it arcing.
Okay.
So in safety, this would be totally unacceptable in Europe. But in China, because it's a taxi driver who does it, he is trained, so they don't care.
You also have quite a lot of people.
What?
You also have quite a lot of people.
Exactly. Exactly. So they have, what is it, 1.6 billion or something like that, similar. So one less or more, but in Iceland we have to be more careful. And also in Denmark. So this kind of things, and of course, don't forget that the German car makers who are in China, like BMW, Daimler, Volkswagen, they cannot allow to have a fast charging standard there, which is not safe. Because their brand images, even though it's in China, can be damaged severely by these kind of accidents. So they cannot accept that the fast charging standard there is not safe. So they are also putting a lot of effort to make this all work. As I said, for us, it makes no difference, because simply we make fast charging standards which can follow all the three, which can follow Shademo, which can follow CCS2 for Europe, and which can follow AC charging for, can charge Teslas with it, but also the Daimler and the Renaults. So, and for those who know, in America, there's also a CCS standard, but that's a CCS1. It's a little bit different because the top of this plug has a little bit different shape than in Europe, but all the communication is the same. So this is how a charger looks like from ABB. On one side the AC for Renault, Daimler and Tesla. In the middle the Shademo for the cars with the Chinese, with the Japanese standard. And on the right hand side the CCS part where you can charge the German and the American cars. We have two versions, a 50 kilowatt version and a 20 kilowatt version. They look totally the same from the outside. The only difference is that in a 50 kilowatt version, there are 5 power modules of each 10 kilowatt. And in a 20 kilowatt system, there are 2 power modules of each 10 kilowatt. And you can buy a 20 kilowatt system and then later put 3 extra power modules to it, and then you have again a 50 kilowatt system. And we have different versions. I'll come back to that later. The only thing what I would like to say is you have seen the projection of the cars coming to Europe with larger batteries in the future. I would not, personally, I would not buy a 20 kilowatt system now anymore. I would go for 50 kilowatt system, because with the cars coming with the bigger batteries, I would not go for a year. But that's my personal advice to you. Okay, just to come back on the point which I mentioned just before we all had a small break. I said I would go for 50 kilowatt systems. I should bring in one nuance. I said, of course, if you put your charger on a location where people will stand for a long time, like a restaurant or a shopping mall, then of course 20 kilowatt is good enough. But if you want to be on a place where people can move pretty fast, then with all the knowledge we have, I would really go for 50 kilowatt systems now. So, especially on highways or where people go fast, there I would really propose 50 kilowatt systems. And as ABB, we have 4 typical systems. We have a combo-only system. This we sold a lot to the German car manufacturers when they were making tests with combo. We have a combo and 22 kilowatt AC system. This we are selling a lot to the dealers of Volkswagen and BMW throughout Europe. But the systems which we, let's say, sell to utility companies.
I was just wondering, why are you limiting it to 50, why not 100?
Because none of the cars can do 100. None of the cars can do 100.
They're coming up.
What?
But they are coming up with the 48 kilowatts. They must be able to do 100.
It's not so simple. So, yes, it is indeed that the Germans are considering to go to higher powers because, you know, Tesla has 120 or 130 kilowatt at the moment. So the Germans are considering to go higher for some cars in the future, but they have not decided yet. So we cannot make a charger when there is no car. And you can think, okay, maybe I make a 100 kilowatt charger or maybe a 120 kilowatt charger, but we don't know at the moment.
Can you upgrade those?
No. No. There's no space to upgrade them. But all the cars which you saw on the map will continue to drive for the next 15 or 20 years. So you need to charge them anyhow because they will be on the roads.
Yeah, and when we get the next generation car to 48 kilowatts, you will have to stop for an hour instead of 15 to 30 minutes. It stops being faster.
True.
In my understanding.
The point is only that in the next 2 years you will not see those cars, because if we are not already working together, so at this moment of time, the German car makers are not testing with more power at this moment of time. So if they are not testing with this moment of time, that means in the next 2 years, 2-3 years, there will be not a car which can do this power.
Yeah, don't you think it's short-sighted not to think about the future 2 or 3 years? Thousands of chargers and it will be almost obsolete in 5 years.
No, as I said, I don't believe they will obsolete, because the cars which are driving now will have to be charged. And if one day there will be a charger which may be 100 kilowatt or 120 or 150 kilowatts, God knows, then you don't want that a car which we have now blocks this kind of charger because you cannot use the charger to the utmost. So we believe that when that will happen, when one day there will be chargers which can do more, that as an operator you will have more chargers on one location, one for, let's say, the cars which can only do 250 kilowatts, and maybe one which can do to more power. So this is what we believe. So we believe that there is no fear that you build up a system which you cannot use, because in the coming years there will be more cars of 50 kilowatt coming on the market, and you will have to serve them also. To be honest, the systems with combo only or combo and AC, we only sell them to car makers. But for all people who are building a network, either they buy CJ versions, combo and CHAdeMO, or CJG, which is combo CHAdeMO, and AC. And this is the charger which we sell most. Sometimes this one is bought as a second charger, so the first charger on the location is this one to have AC, but as there are not so many AC cars, then sometimes the second charger close to there is this one. This one is the charger we are selling by far the most at the moment. And I said, this is the 50 kilowatt range. Typically, with the actual sizes of battery, you can charge your car between 15 to 30 minutes. For areas where people will stay longer, like shopping malls or maybe offices, so where people typically stay maybe 1 hour, there a 20 kilowatt charger will work. It looks like the same picture, it is, and as I said, there is not 5 power modules, but only 2 power modules into those chargers, and then you can get 20 kilowatts. But nowadays we are selling less and less 20 kilowatt system, and more 50 kilowatt system. And if you want to have price information, I don't give price information, but then, yeah, please contact Rönning here, and they can give you price indications. DC wall boxes. In my presentation, I have shown this DC wall box, which we make for Denza in China, and this DC wall box, which we make for Porsche. We are also considering to make a DC wall box for, let's say, normal use in Europe. Don't think that those boxes are small. Those boxes are really this kind of size. It's not like an AC wall box this size. They are really big. But for the moment of time, we are not supplying them. We are now in China. So this was the first generation of wall box with Porsche. We are now working on a second generation in China and trying to make the price go down, because the price at this moment of time is too high to offer. In China, we are getting volumes, and when I talk about volumes, you must think about thousands and 10,000s of pieces. That is the type of volumes you think in China. Once we get the price down in China, then one day we will also launch maybe a DC wall box for home use or for other use in Europe. But in China, we first need to make the volumes. So we don't expect that that will be in this year anymore. If it will happen, then it will be in somewhere in 2016. On these chargers, you can run AC and DC at the same time. So you cannot do CCS and CHAdeMO at the same time, but you can do CCS and AC at the same time, or CHAdeMO and AC at the same time. And I'm not going to give you all the details, but this depends also on the fuel size which you use to connect the charger. So if you, these are 50 kilowatt chargers, so take this charger. If you really want that, yeah, let's say AC and DC can really run together, then probably you need to go to 3 times 100 amps or higher in your fusing. Because if you are lower, then AC and DC cannot run really fully together. And the details we can explain you if you have more interest to go more, but just be aware that AC and DC can run together depending on the fuse you use.
Can you clear a little bit for us what's the difference between AC and DC? That's it alone.
The difference is basically, as I said, the difference. AC is the grid is AC. The power which we have in our homes is AC, but the battery of a car is DC. So if you want to charge with AC, if you want to charge an electric car with AC, the car itself must have an onboard charger which can convert AC into DC.
But if you have a charger that is going to put AC output, how do you do it?
Then your car must have an onboard charger, an AC
Just
charger.
supplying the onboard
No,
charger.
it's in the car. So in those cars, like Renault Zoe, Smart, and this one, this charger, in fact, is either can go up to 22 or 43 kilowatt. In fact, in the Renault Zoe, in the Daimler Smart, this indeed is a 22 kilowatt onboard charger. In the Zoe, they do a difference. They have the electric engine, and they use that reverse, and by that they can charge by AC. So, and that makes the car complicated. So you have, in those cars, are in fact more complicated because they need to have the onboard charging capability, the onboard inverter, into the car. And in this inverter, they make AC into DC. But many car makers don't like this because, yeah, this is extra cost, extra weight, and it takes space into the car. So that is also the reason why the AC fast charge you hardly see. Most of the car makers, I showed you, most of the car makers, they don't go for AC fast charge, they have AC slow charge. So they have this inverter, this converter they have, but only for a small power level, only 3.6 or 7.2 kilowatts. They don't want this bigger. Because
When you're talking about AC charger,
yes,
are you just supplying the charger in the car?
then we supply charges. We supply 43 kilowatt AC via a cable, but the car must have this inverter. So this is only to charge a Renault Zoe or a Daimler Smart or a Tesla, for example. For the other cars, it makes no sense. For the other cars, you have this. But it means that if you have a charger like this, you can charge a BMW i3 at the same time like a Renault Zoe. They can stand together at the charger and they can be charged simultaneously. So for people who make money with fast charging, they like this because they can send a bill to the guy who comes with a BMW i3 or Volkswagen e-up at the same time as a Renault Zoe. So they can be charged at the same time and they can earn money by charging two cars at the same time. So for, let's say, a lot of commercial operators, this is important. Yeah, because they can handle.
But then we have to be able to supply big power source to it.
Yeah, then you need, as I said, you need for a 50 kilowatt system, you probably need, yeah, around 3 times 100 amps or higher. This is a part where I will speak about connected services, how the chargers can be connected to a back office system, or because once you have a charger, it's nice. You don't need all this kind of stuff, in fact, because if you are a dealer, for example, a car dealer, we have sold chargers to car dealers, and they said, look, we just want that our charger stands there, that it runs 24 hours per day. We don't want to make money with the charger. We don't want to send a bill to somebody. We just want that the charger works. Then you don't need any of this stuff. It just stands there and it works and it works and it works. I just make a small wire, but in fact, 99% of all the chargers we have worldwide are connected via GSM. So when we sell a charger, there is a GSM modem in the charger. and we supply the SIM card. You don't pay for it, we pay for it. And the chargers are all connected to what we call the Network Operations Center. And in the Network Operations Center, we can check if the chargers work well, and also we can see if the charger breaks down. We can remotely look into the charger, and we can see what is going on, and we can reboot the charger, we can download new software, all those kind of things. But for that, you don't pay.
Sorry. What about the utilities?
What?
What about the utilities, the power utilities, the communication between the chargers and the utilities itself?
Yes. There are different ways how we can do it. So to explain is that what we call as connected services connects the car. So as I said, there are 4 different standards, CCS, CHAdeMO, GB standard AC, and utility companies or operators normally have a back office system with which they can bill the customer. And there are many different back office systems. Some people develop their own system, but you can buy systems from SAP, HP, MobiE, PointPoint, Bosch, many possibilities. And what we do with our connected services, that we connect this world to this world. And there is a nice slide. Is in fact, there are 3 kinds of functionalities. The functionality to connect to a back office system, where you can do authentication and billing, and where you can handle customers, subscribers. A system in the near future where we will also look to the grid side, like smart grid systems, where you make sure that if you have more charges on one location, that the total power of the charges will not exceed a certain level. That's the grid side. And then the charger management is that to ensure that the charges stay running, that there is software updated, all these kind of things. Those are 3 different functionalities what we see. As I said here, there's many suppliers of back office systems, like Now Innovations, Bosch, SAP, whatever. On the smart grid side, companies like Ventix, IBM, HP are involved. And on the charger management functionality, SEBD, but also more. What we do is that we make connected services here, and we make interfaces through which the back offices can talk with the chargers. And typically, we have started already 4 years ago with that, and now it has become, let's say, a standard in the charger world via an OCPP interface, Open Charge Point Protocol. All the back offices can talk to the chargers. And via a POI API, this is also an application program interface. This you can use, for example, to show on a map where the charger is located. So this communicates the location of the charger, and it communicates also the status of the charger. If it is free, if it is charging, if it has a technical problem. And with this kind of information, you as a customer, you can connect billing systems to the charger. By now, I think we have done around 35, 40 different back office connection to customers. So customers like E.ON or Clever or Fortum or any other big utility that you can name, we have connected their back office to our systems via those 2 different application program interfaces. And for the future, we are also looking to do smart grid systems, either via OpenADR or via this SAP 2.0 AB. We are looking into this now, and we'll come up in the future with this kind of systems.
Is the utility itself talking to the charger over the GSM network, or is Are they talking to you guys, to your systems?
They go via our systems to the charger. Yes. And to be honest, as I said, we have sold 2,000 chargers. So in the beginning, let me put it like that. In the beginning, a lot of customers says, no, we don't want it. We want to go directly to the charger. Then they realize that when they go directly to the charger, nobody is checking them. So if you go via us to the charger, we measure. So first of all, we have a network operations center which is ISO 27001 certified.
ISO 27000, yeah.
Exactly. And we measure the communication between you and the charger, and we can see if somebody is willing to break in or not. If the traffic is normal or the traffic is hampered. So what we have seen that in the beginning, some customers said, no, we don't want this. We really want to go directly, and normally after some talks, they prefer our system because we don't keep any data of the charger, of the customers. We only look to, let's say, charging related data, but we have no names of customers or something. That is all in the back office. So this is not a problem. And for the customers who really cannot live with that, we have another solution. But in fact, so far we have not used it. At the end, all the customers said, no, I prefer this because it's more safe.
Only one knock.
Huh?
And you are running the network operation center. Only one needed.
The network?
No, the network operation center, you are running it.
Yeah, because the operator software, you cannot do it. Nobody, I don't believe that for any charger in this world, another customer can really do the upgrade of the charger, because you don't have the knowledge to do it. The charger has over 400 parameters. If you put one parameter wrong, in principle you can have an unsafe system. So if you are not the designer of the system, how can you then put new software? It's impossible, I believe. So, and also, our philosophy is that you should worry about this kind of things, about the billing of your people. You must make sure that you should not worry about the charger. The charger is our problem. It should run. That is important for you. It should run. Our chargers typically have uptimes of 99.7, 99.8%. We can do this because all the chargers are connected. So from all the failures in the charger, we can learn, and we can study the log files, and we can learn. None of our competitors can do it in the way we do it.
I mean, it's more a question for the utilities, maybe, how much energy is being drawn from their systems.
Yeah.
So they want to be able to see how much energy is being taken from the charges.
Yes, you can see.
If you have to put in.
Yes, you can see everything. Because via those application program interfaces, you can see when a charger is starting, when a charger is stopping, how much energy is taken. And you can see, let's say, the RFID card number, but the information of the RFID card is in your back office system. We don't have any of this. So the name of this person, all this kind of stuff is here in the back office, not in the charger. But all this kind of information you can see. So there's a thing you don't have to worry about. And I said there is multiple big customers who have already connected to this kind of system. It's the most reliable system in the market, but I will come back later to why it is. For Europe, for 33 countries, we also have the possibility to use a credit card system. This is an agreement we have with Deutsche Telekom, in fact. And via this credit card system, you can pay via credit cards, debit card, or NFC. And yeah, basically it works in 33 countries. It can be fuel upgradable. It has a very low cost, in fact. And so, yeah, this is also a solution which basically is available. For customers who have so many customers, they start out with a small network. And once they grow to a bigger network. And what you see is that customers who are starting up with a small network, in the beginning, either they don't want to make money with the fast chargers, or they have no business case to really install a real back office. So they want to have a simpler solution, and that simpler solution can be what we call Operator Pro. This is a solution which we have available. For the moment you buy a charger, we can connect it, and you via a web, you can see what the charger is doing. You can switch it on, you can switch it off, you can make an export of an Excel file of which charge sessions have taken place. You can either use RFID cards, or you can use PIN codes that not everybody can go into the charger and can use it. But as you said, bigger utility companies, they normally have a back office system, so they are not really into this. They really want to connect to a back office system, what I said before, via an OCPP API or a real-time status API. So it is a choice. So for those customers, professional back office system, the OCPP APIs, for the smaller networks, we have a solution available which people can use. It's not a big back office system with where you can charge people, but at least you can see what is happening with the charges. You can make sure that only people with an RFID card can go there and can use it. And you can add RFID cards or block RFID cards, all this kind of stuff. So there's different solutions here. I will not, because if you want to see it, I can just say maybe follow the link here. There are 2 YouTube movies where you can see about this Operator Pro, this system for smaller networks. And we also have a second software called Driver Care. I can advise you to look at those 2 movies to see, okay, what kind of functionality do I have? As I said, you can see what is happening in the charger. You can get statistics of the charger. You can change parameters of the charger in the sense that you can change the name, these kind of things. You can see advanced statistics. You can export all the data. You can manage RFID cards or PIN codes. And in the Driver Care solution, this is especially for larger networks. They can also have an automatic system where they can communicate with the ABB servicing centers and start cases, and also get advices when a car, for example, a BMW i3 car comes to a charger and there is a problem. Then you can find out, okay, what could be the solution, what could be the reason for the problem, and some solutions can be mentioned. But for this, I would advise you, please look at the movies. The presentation, you can get it, no problem, and then have a look there to see what can be done. These are for the bigger networks, for the connection to the back office system. the OCPP API. That is strong interaction with the charges based on transactions. So everything is based on transactions for payment. Charge point management system, charger to charger, master slave systems, payment solutions. We have OCPP version 1.2 and 1.5 implemented already. And once a customer wants to go into here, we have a full guided process, a booklet, where together with him we will run through the whole process, how to make this implementation. As I said, we have done probably around 40 implementations by now. And the real-time API, this is to get the information about the charger and its connectors. And you can show this on a web page, on a map, for example. I will give you an example about that. And yeah, this is the book. This explains the whole process. So once you decided to go into a connection of your back office to a charger, the first step is that you get this book from us, which explains exactly the steps we are going to do. And we have a 6-step approach to make all this kind of testing. So first we connect, first we have a kick-off meeting, then the customer implements some messages into the system. Then we do stop testing, then we do testing with a charger simulation, and then at the end we connect it to the real system and we go live in 6 steps. So this is really a full system which we have learned from the past. If we do it like this, normally a professional back office can be connected. We have had connections in 2 to 3 weeks time, when all this was working in 2 to 3 weeks. This is a picture of the Network Operations Center in Holland. Here all the charges can be seen from the road, so we can see if the charges are running smooth, if they see any mistakes. We can also see the amount of traffic on the communication. So if we see that the amount of traffic on the communication suddenly goes high, it means either somebody is trying to break into the system, or for example, that one of the back office of our customer is not working fine and is sending too many messages. So then we can call the customer and say, hey, looks like your back office is sending too many messages, please have a look at it, because we think this is not a normal behavior. And also from our development department, as I said, we can download new software. If there is a problem with the charger, yeah, we can look at the log files and we can see exactly what is going on. And also if, for example, in the 50 kilowatt charger, one of the 5 power modules is breaking down, we can remotely switch off this broken power module. The charger can continue with 4 power modules, so it's not breaking down totally, but it continues with 40 kilowatt instead of 50 kilowatt. This is an example of, as I said, we have this POI API, this real-time status agent, which you can use for showing your information on the map. Well, this is the map from Estonia. So if you click on this website, you can see this map. You can see all the charges on this map, and you can zoom in, zoom out, and you can see if the charger is free, if it is currently charging. There's a couple of here. This is Tallinn. And you can also see if a charger is under construction or broken down. And this kind of information, also you as a customer, you can make these kind of maps and you can show this kind of information from the charger.
Sorry, well, you can see a charger is currently charging. Can you see how time gonna be charging? Any more details? How far he is with the charging?
No, I don't think. Here you can see there is a system under OCPP 1.5. You can make reservations. But in fact, we have not implemented any of them for one of our customers, because many people say, yeah, I need a reservation system, I want this, and then they start realizing that this is not so easy. Because what happens if you reserve a charger, so you reserve, let's say, this charger, and you reserve it at 10 o'clock. So now a car comes at 5 minutes to 10. Should he be able to charge or no? No, so he should not be able to charge, because the other guy has reserved the charger. But if now this guy comes later, what is happening? And all this is not so easy, because if he is not turning up, if he's turning up too late, are you giving a penalty? Are you giving cost to him? How are you handling this? And so far, many customers of us said, yes, we are interested, we really want this kind of reservation mechanism. But at the end, we see that none of the people have implemented it. Because the what if, and if he comes, if he doesn't come, are you going to charge him? All these kind of things are not so easy.
Might be smart if you could just look at currently charging status when it was plugged in or something. That's an idea. Might be free after an hour.
Yeah, but you don't know.
No.
Because you don't know if the car is still there. Because even it can be free, but if the car is on the parking spot, you can maybe still not charge. So this is not so easy, unfortunately. So yes, we have been thinking about this, but the solution is not so simple. So this is the reason why on points where there is much more traffic, like I gave you an example of Fastnet in Holland. They have 2 to 4 chargers on each location. So just like a gasoline station, they just put more chargers. They say then, okay, then people have to work to wait shorter. And of course you only do this at places where not so much cars are running. But on, they are only on highways, so they say, okay, on highways there will be very fast, and people really want to move fast. They don't want to stand long time, they really want to stand there, take a cup of coffee, and then take a piece of bread and then drive away now.
Do you know the price of kilowatt hours in Estonia or Netherlands?
Yes.
What are the some?
Yes, I know all those prices. I have a, maybe if you come after our meeting, come to me.
Yes.
I made a presentation in Luzern about 1 year ago, and there I gave an overview about what kind of prices are normal. Just to give you some idea, most of the customers, but maybe Jonas, will you, maybe Jonas will you in your presentation you will show the payment schedules of Clever or not?
No, not directly the payment schedule.
Okay. Okay.
The different options.
Okay. Well, I can show you the different payment schedules they have. It's all on the internet, so it's all public information. I'm not showing you anything which is not public. Typically is that in Estonia the prices are quite low because this is a government-sponsored system, so they don't want to make profit with it. Typically they have 3 packages for people who don't charge a lot. They don't have to pay a monthly fee. So the monthly fee is 0, but I think they pay something like €5 per charge, fast charge. And then they have a middle system where you pay a little bit monthly fee and a little bit fee per charge. And for the real heavy users, you pay a higher monthly fee and a smaller fee per charge. And this is also what you see in many other countries, that there are 2 or 3 different payment schemes. So in fast charge in Estonia is probably around €5. A fast charge in Holland can go up to 11 or 12 euros on the highway. Because there the company says, okay, it's on a highway, so it's a location, it's a highly valued location, so I can ask a little bit more. And so then it's around 10, 11, 12 euros. But I have a full overview of what is happening in Europe there in my computer. As I said, in Estonia, so for customers, for utilities, when they have a good back office system, you can use either SMS payment, smartphone app payment. And in Estonia, for example, all the chargers have a QR code on the charger. So just via the app, you make a picture of your of the charger, and then the smartphone app recognizes this QR code. He knows which charger it is, and then you can say, okay, I want to charge 20 minutes or 30 minutes, this kind of things. They also have RFID cards, and in Estonia also they have a prepaid RFID card that I don't see back in many countries, where people can buy a card with, for example, 25 euros, you can have 5 fast charges for 25 euros. But all these kind of things, you can define yourself depending on the issues of your back office, the possibilities of your back office. These are my last 3 slides. Why ABB? First of all, our chargers are made of stainless steel. We believe that when you buy chargers, you buy them typically for 10 years or more. We believe that normal steel is not good enough. We believe that stainless steel is good enough. If you compare to competition, you will not find this back in competition as a standard product. This is an important one. Our chargers are designed according to 610063, which is the EMC requirement required for residential areas. As far as I know, almost all our competitors are according to this one. This is industry standard, so they must put warnings on their chargers that if you have a pacemaker and you can come close by your charger, that you might have a problem. This problem is not with ABB chargers. Also, I don't know in Iceland, but in Holland, a charger which has an industry standard, you cannot connect to a transformer which is connected to other residential areas, because the whole system goes down to the lowest level, and industry standard is lower level. ABB chargers are defined for residential areas. Another important part is that all these things on low voltage directed, electric safety and EMC, we have a third party measuring this for us and a third party certifying us for this. So when you buy an ABB charger, you know that it fulfills all the EMC requirements, all the low voltage directives, etc. Many other cases, you will see that the CEO of the company, of the other company, have made a self-certification that he says, I herewith declare that my charger is safe. Okay. Up to you, if you want to believe them. We believe as ABB that we should not play tricks with this, and we don't do self-certification. We have a third-party independent certification. We have the highest uptime of the market. We can do in-depth remote diagnosis and remote curing. We can do remote server updates, and I told you in the beginning that for the CCS implementation, at the moment we are running on a DIN standard, and one day we will go to ISO. But also we believe that every new car which comes to the market probably will need some adaptation of the software, because you can have a standard. But you also know that the standard can be interpreted in a couple of ways. So a standard is never fully a standard. There is always interpretation of a standard. That is also one of the reasons why we really want remote server updates. We don't have to go to all the chargers with a computer or with a memory stick. We can do it remotely. On purpose, we have different power modules. Many of our competitors have one big power block of 40 or 50 kilowatts. When something breaks down in that power block, the whole charger is down. And then you have to wait till a service engineer comes there and repairs it before it can run again. In ABB, we have in the 50 kilowatt systems 5 power modules. In the 20 kilowatt system, 2 power modules, each of 10 kilowatts. If one breaks down, we can switch it over remotely, and the charger can continue with the remaining power. Our chargers have a 3-door concept, so if a service engineer comes there, he can open the 3 doors if he needs, and he can exchange every module within 20 minutes in a charger by swapping. So we don't repair a charger, we never really repair a charger, we just swap modules, because by that we believe we are much faster. Our chargers, our 50 kilowatt chargers, can really run 50 kilowatts for 1 week. This is especially important when you charge Teslas with the CHAdeMO adapter. Tesla has a big battery, 85 kilowatt hour. So really, in order to fill a Tesla car full, it can run maybe 1 or 1.5 hours. Our charger can really run this time on full power. Other chargers will switch down remotely, or will switch down the power, or there are chargers which can only charge on full power on 25 kilowatts for this long amount of time. We have lower noise levels. Why is this? Because we have 5 power modules. Each of those power modules has their own fan. So because of that, we don't have to blow all the air through the whole charging system. But we have 5 different power modules, and we can blow the air through with 1 fan per power module, and by that you can reduce the total amount of noise in the charger. Our chargers, CHAdeMO, are version 1.0 certified. All competitors have the outdated version 0.9 certification. And you can check this, go to the CHAdeMO website and check which chargers have a 1.0 and a 0.9 certification. Our delivery times are typically 4 to 6 weeks now, between your order and between ex-factory, and then comes to it some transport time. Many of our competitors have much longer times here. For payment system, credit card system, this can be retrofitted to any charger. Our competitors don't have this kind of system. We have certified ABB service teams in many countries. We have cloud connection and connected to over 40 backup systems. Our charger is roughly half of the weight of many other chargers. We have the largest installed base of chargers in the world. We are available at the test tracks of some German automotive companies, not only at the polar circle, also in the desert, but also in Germany and France. And the chargers here are used 24 hours per day, 360 days per year. So only during 5 days per year, they are not being used. All the other days, they are really driving 24 hours per day. So by this, our chargers, because I have seen a competitor saying that this charger in Germany is the highest used charger. It's not true. These chargers which are here at the test tracks of the German car makers, those are the ones which are used most. They are constantly 360 days per year, 24 hours per day, they are being used. We are a global player, and I told you in the beginning that we are also active in solar, energy storage, power quality. And one of my first slides is that I showed you that ABB bought a lot of companies, that all the software connection will happen in the future. For smaller companies, this will be difficult to follow this game in the future. So, basically, my presentation. And if you have any questions, please let me know.
Are we able to have it with a dual shuttle? Charging two vehicles, the same standard, but
at the same standard.
doesn't matter.
2 combo.
Yeah, 2 CCS perhaps.
And the reason that first of all, we did not have any request, and secondly is that when you do it, you cannot charge them together. You cannot charge them at the same time.
Because in some version I think that they are able to do it, but I mean that the power will go down. It will take longer to use.
Yeah, we believe this is about philosophy. Is first come, first serve. So we believe that when first the CCS car comes, for example, he plugs it in. The moment he plugs it in, he can see on the display that it will take maybe 25 or 30 minutes or something like that. So based on this information, the guy will go away, take a cup of coffee, and after 25 minutes come back to his car. If a second car would influence this, we don't think this is good, because the first guy will walk away believing that his car is ready in 25 minutes, and then a second car comes and then uses his power, and he comes back, he wants to drive away, and then he finds out that his car is only half full. So the system we have implemented here, and I said I can spend much more time explaining all this, is that first come, first serve. So the first one who comes gets his full power, the second one who comes gets the power which is over. The good thing is that if you look to the power curve, if this is power and this is time, and if you do charging via with DC charging, you will see that the power goes quite fast up, and then goes to a maximum, then stays sometime flat. Goes close to a maximum. Goes to the maximum, and then starts going down quite rapidly, because as the battery becomes fuller, the speed of charging goes down. Otherwise, you will damage the battery.
Yeah, you will not charge the full
Never.
Full power, except maybe 10 minutes or so.
Yeah, so normally what we see as fast charging normally is to 80 or 90%. Because if you want to charge the last 10%, you have to stand there a long time, and the speed of charging is going down, because the battery management system, they say, tries to save the battery. It's not going to allow that more power goes into it. So most of the drivers, when they have reached something like 80 or 85 or 90%, they say, okay, now it's good enough, now I drive, because for this last 10 or 15%, I'm not going to wait here anymore. Because that takes a long time, and my range is only growing slowly.
Now the question is regarding the case itself, the machine itself. How was it tested? Because without doubt it has a high IP68 or something like that. But even though, because of our weather condition here, where we see maybe rain in a vertical position, and sometimes it's like the blasting machines.
It's IP54, and the against Fyrirlestur it's IK10.
Yeah.
If you have, if you look to most of the implementations, like in Denmark, Norway, Sweden, Estonia, the charges are just standing free. In case you expect really bad winds, then sometimes they put on the tree side a kind of protection house around it to protect this.
It's mainly the water I'm considering. So it's about, because that's always an issue, because it's a machine like this, like 54 without for long term.
We have to check with you, and please make contact and we can discuss this. I have not seen many cases with this, to be honest.
I know that, but that's mainly our problems here, because they are always tested in some cold areas. In cold areas, we don't have that much humidity or rain or anything like that. But as our weather condition here, a lot of rain. It's like it's plastic.
So we have a lot of charges. Maybe it's different around Stavanger area, this kind of stuff. Maybe.
Also the battery there and zero power would be enough. But also another thing regarding the charger, you mentioned that when one of the multiple breaks down, you take it out and put something in. But do you repair it or do you throw it away?
They go back to the factory, and I think they are repaired as a spare part, but they go through all factory testing in them. So some cases we have some old chargers, for example, which we refurbished. We don't do this anymore. But in that case, also the charger really went back to the factory, checked everything, went through full testing, and after that shipped again to new customers.
That will probably mean that if we bought a refurbished one, that cost like 8% of the new one.
Yes, as I said about cost, I am not going to discuss about cost. Please ask with Rönning and my friend Jonas.
Excuse me. What precautions are taken in the manufacturing or design of a charging station regarding harmonics influence on the network?
I cannot tell you all the details. I know our harmonics are low because I know that we had quite some questions from customers who want to know really the measurements. So as I said, the measurements have been made by a third party, and we are willing to exchange to them. So if you are interested in this kind of information, and if you sign a non-disclosure agreement with ABB, then we are also willing to send you all the detailed information about this. But I can tell you our charges are quite good. We are willing to share this, but then we want that there is a non-disclosure agreement in place.
So it's a secret.
No, but we just don't give all the measurements away to everybody. And we think when we send this kind of information, then at least there should be some kind of non-disclosure, which is very simple. It's a very small thing. It's a dual side non-disclosure. So for you and for us, the same rules.
Okay.
That's one more question.
Have you tested the 7-mole adapter from Tesla with those stations?
Yes.
Will it give 450 kilowatts or how much? Do you know?
Yeah, a little bit less than 50 kilowatts because this is determined by the software of Tesla.
Okay.
But we know that we can run almost on full power level, really all the time without any problems. And we know that, in fact, I think none of our competitors can do it. Some competitors, the charger will, when it gets heated, they will either switch off. There are some chargers which were burned down. So for those chargers, Tesla in fact reduced the power to only 25 kilowatts. And some other chargers, they will reduce themselves because they cannot deliver so much power for such a long time.
Do you know that how many kilowatts it will deliver? How many kilowatts the Tesla will take on those stations?
I think probably around 46 or 48 or something like that. But as I said, this is determined by the software of the Tesla adapter. So this is almost 50.
Has all manufacturers made some agreements for this battery packets 8 years warranty by using, or do they make some what is in the small lines for these 8 years agreements on battery packets from the manufacturers?
The point is that the battery management system communicates to the charger, and if the charger does not follow this curve which is given by the battery management system, then normally the battery management system will switch off the charging. So
normally what you do is that you test as a charger manufacturer, you test. Therefore I said it's so important that you work together with the car makers, that you do very regular testing, because also the car can make a software update. Huh? Because sometimes the car makes a software update and they change something. So there it's very important to work together with the car makers. And we as ABB, I cannot speak there about competition, we try to work really very close with them to make sure that there is really no problem. But sometimes it can happen that when a car comes on the market which has not been tested with a charger, that there is a problem. And that's also one of the things we really try to avoid, to work together with the Kias, the Hyundais, with the Fords and the GMs and all those guys, and to make sure that once a car comes on the market, it is tested with the charger, and that if we need to make some adaptation in the charger or in the car, that is done before the car comes on the market. Because people normally, when they connect the charger to the car and it doesn't work, they say, this is the charger, you know. This is not true. It can also be the car, which is not working well. So that is the thing you have to analyze and to see what happens. Because the strange thing is that for Shademo, they have a certification of the charger, but they don't do really a certification of the car. We are working on that at the moment with Shademo. CCS is not so far at all. What CCS does is they, once in a while, they invite charger makers, charger manufacturers together with car makers, and then they try. But this was especially done before the cars came to the market. Now the cars are on the market. Yeah, I think it's really up to the charger and the car maker to make sure that this really stays working. So it's a lot of effort.
You mentioned also on one of the slides that there were this number 1 and 2 sockets for States and Europe.
Yeah.
Why isn't it the same one?
It's a good question.
Because it was on the market in the US and Europe didn't just want to do something else.
It's almost the same. It's almost the same.
Can you just change the approach?
The reason is that in Europe, so as I said, combined charging systems need combined AC-DC charging. So for AC charging, in Holland we have the Type 2. You know Type 2 connector? Does it ring a bell, Type 2? No. So for AC charging in Europe, you will see a connector which has this shape. So a little bit flat here and then round here. And then in here there are pins. This is protective earth. This is communication. And then normally there are 1, 2, 3, 4 pins around it. One is 0 and the other one are the 3 phases. That is AC. For DC charging, they don't need this 0 and the 3 phases. They just need the protective earth and the communication. And for the plus and minus, they put this part below it to really make the plus or minus of 50 kilowatts. So in Europe, the combo connector is a combination of a Type 2 of the AC and a DC part. In America, they did not have the Type 2 connector. They had the Type 1 connector, which is a round connector. It's around this size in reality, but totally round. And in America, the CCS1 is a combination of this round connector on the top here and then the 2 plugs. So, because their AC plug is different than our AC plug. But all the communication is the same. So for the car makers, it's very easy. But it's just because the Americans had another AC type of plug.
I am Jonas from ABB Denmark. I've been here a few times before. Basically, ABB Denmark is doing business with Johan Rönning, serving more or less all ABB products. I've been with ABB for 12 years now, and I'm also doing e-mobility, which is a great new business area for Viking for I think 4 or 5 years already. Stephen is in the product in the Netherlands. And I'm doing local sales in Denmark, but also Iceland together with Johan Rönning. And I'm basically not going to talk about products or technical features, but mainly the story about Denmark, because Denmark is one of the countries in Europe or Scandinavia was actually a first mover on e-mobility. Stephen has mentioned some other countries, Netherlands, Estonia, and now I think all the countries in Scandinavia is really coming up, Sweden, Norway, and so on. So please interrupt if you have questions along the way. I should spend only half an hour, unless you have a lot of questions, of course. First of all, here is, let's say, the history of the e-mobility of the Denmark. So back in 2011, we were very proud to actually install the first full public DC fast charger. At least it was the first one in Denmark. I'm also 100% sure it was the first one in Scandinavia, and it might also be the first one in Europe. Actually, very early. This was really a prototype. It operated in central Copenhagen for actually 1 year. And then just half a year later, we actually had Stephen and his colleagues in the Netherlands coming on board. We bought this company Pion in the Netherlands. And then things really started moving because we really bought the right technology. You can see that today. So we made a business corporations back in 2011 when we started the first fast charging installation in Copenhagen, together with a company called Choosy, which I'm sure you can see, but it's on the side here of the charger. And Choosy is now today has a new name, and they're called Clever. If you have heard about them. In October 2012, we really signed the first big frame agreement with Clever. So a deal about 50 chargers that was to be put all over Denmark to make a nationwide DC fast charging network. And Clever were really the first ones really to invest in this in Europe. And I think that we can say that they did it very successfully. Only within a few months, I think less than half a year, they had the whole system in operation. So by the end of, I think by the end of 2013, there were already 50 fast chargers in Denmark operating. We had at that time 100% market share from Sweden. Then in 2014, after we had a very close partnership with Clever for many years, for 2 years, also E.ON decided to invest in Denmark. The story behind this is that Better Place, which you might have heard about, some of you, they also invested in Denmark already from 2012. They were doing this battery swap system on mainly Renaults. But in late 2013, they stopped the operations in Denmark. So they really, full stop, and everything was basically taken over by E.ON. And they had built up a huge network of these swap stations, I think 18 units or something like that. But they also had a lot of AC chargers, which was then bought by E.ON. And we actually made a frame agreement with E.ON late last year, in 2014, for 40 fast chargers, which now E.ON is going to put up in Denmark. You can say more or less next to Clever's installation. But they have actually two different philosophies about how they want to do it. So in general, Clever, they are doing fast charging on locations where people, they go and buy their whatever, clothes, or they buy their food, or they just have stuff for another reason, on a library, on a hotel, or a shopping mall. Can be different stuff. And that's where they are. And E.ON, they mainly focus on highway locations. So they have put all the fast chargers in the highway locations, as you can see. And they were doing even more. So they're doing, let's say, operations, corporations, but they also somehow on the fast charging market split it a little bit right now. But I'll put more back to that. And then recently, what also happened, I'll not talk about this today actually, but I just thought this should mention this. And this is a new business area for ABB. We are developing a fast charging system for electric buses. And we are in close cooperations with mainly Volvo for start. And in Denmark, we have established very close cooperations, and I think that we can say we have like, I think 6,000 buses running in large cities in Denmark, and at least 50% of those can be transferred into electric during a short period of time, maybe 2 to 3 weeks. So it's a huge market, and we are already seeing public tenders for electric buses in Denmark, so it's very interesting. Another thing that I'd like to mention is also that by the end of this year, the number of full public fast chargers that everybody can use, either if they are a member of the Clever Club or the E.ON Club, or if they just have a smartphone, then they can actually do fast charging on more than 100 fast charging stations. And I think that's a world record, because if you look how many fast charging stations do we have per electric vehicle, it's quite a lot. And also how many fast charging stations do we have per inhabitant, or the size of the country and so on. So it's really, Denmark is really a front runner on this infrastructure. And not just on on DC fast chargers, but also on AC public charge stations. But we'll come back to that. Our customers from ABB in Denmark are not that many, because we have more or less chosen only to work together with first Clever and then E.ON, because they basically cover the whole market for us. But we do have a little direct sales also to a university who's very involved in research and development for e-mobility. So they have both Volkswagen and Nissan also have a few. So this is our customers. And who are we in Denmark? First of all, of course we are not, we can count all the people here, I think we have more than 12. We don't have 12 people working full-time on e-mobility. That's not what I try to say, because the market is not that large. But actually we are 12, 13 people involved. 2 on sales, technical support, we have project management, and especially very important, we have a service hub. So in Copenhagen, in our facility, we do have people sitting ready by the computer, by the phone, actually online connected to all our chargers and equipment. They can do service, remote diagnostics, and help our customers if they have problems with the chargers. So that's a very important thing. You really need to be able to service your network, because one thing is that a charger can fail. It happens from time to time. But the drivers, the new e-mobility owners, they also tend to do things wrong. So a lot of the failures we see is actually just people that has to learn to do things right. Because it's just easy to call up and say, hey, it doesn't work, instead of trying to find out things yourself when you're out there. And if nobody's in the other end, then it's a bad story. And you get bad stories on front page of the newspapers, and nobody like that. So you really need to have a good service organization behind you. And of course, we also have service engineers in the field, mainly doing the service level agreement, which I also mentioned here. We have service level agreement and 24/7 on-site system agreements with our customers in Denmark. So this is really who we are, and this is needed. If you want to have an electric infrastructure in Iceland, you need to think about service, maintenance, and online support for the system. Otherwise, it will be customers not happy with the operations page. That's what we learned. Another thing which is worthwhile mentioning, because it has actually been very important for Denmark and the reason why we are where we are. We have mainly two different associations, which I will mention today, and we have more, but these are the primary. This one is called the Dansk Elbil Alliance, and this is basically a group of people who is being paid by their you can say members, which is, for example, B, can also be utilities, utility manufacturers, and everybody who is in the utility business. And they got together, made an association, which is basically doing a lot of lobbying for utility. So they influence politicians and different customers, communes who want to invest in electric vehicles and so on. And recently this group actually made a lot of work in political lobbying to make sure that the taxation is kept on a very low level for electric vehicles. There's a whole story about it. But this is very important for let's say a business area, a new business area like e-mobility, to try and get people together and actually go in the same direction. And this is exactly what they do. So something like this would be nice to have in Iceland if you want things to get moving. And of course, I promise these people that if anybody, of course you can search their webpage, and if anybody wants to talk to them, you're welcome to contact them and talk about what they do, because they actually know quite a lot about mobility. Then similar business is actually being done, and this is only for Copenhagen. So the region of Copenhagen also made an e-mobility group, which is focusing basically on the same thing, but only to support the business and growth of e-mobility in Copenhagen. So they know quite some things as well. Then another thing which is of course very important and is the driver for e-mobility all over the world, on the shoe line, mega city in China where people die from pollution, then it might be a little bit different driver. But you really need frame conditions for electric vehicles, and this is why you need somebody to lobby for that. That's very true, because the gasoline industry and other industries that has different interests than e-mobility, they are of course very strong in lobbying. So if nobody lobbies for e-mobility, then it will be slow. It will develop slow. So what we have, the basic frame conditions for e-mobility in Denmark is that we pay the full VAT, so there's no, let's say, benefit for that part. But the good stuff is that we pay no tax, and the regular car can be up to 180% in tax. So clearly this is a benefit for the electric vehicle. It should be cheaper. But then the car manufacturers are not that willing to sell their cars, so they actually price the car a little too high in Denmark, just to be sure that not too many EVs go. But you can say for small cars, then prices are quite on the same level. And then if you then consider the running costs for the energy and services and so on, then it's clearly cheaper to have an electric vehicle compared to a normal diesel or gasoline car. And exactly this point has been for discussion. I think back in 2012, it was decided to remove all the taxes, and of course then really people started buying electric vehicles. And this was then renewed year by year, but for 2015 it stopped. And only 1 month ago the politicians said, okay, we will renew it one more year. But that has been a big problem, because all the investors, they need some certainties that the frame conditions are the same and they can still count on, let's say, good conditions. So to be only half a year in advance, that's not good. It's simply not good enough. For example, when Volkswagen, they are planning how many cars do we want to sell in Iceland for 2016. This is happening first quarter 2015. If they only order the cars after the summer holidays, they will not get all the cars. So that's very important. So we have been struggling with that, but the good stuff is that now we finally have no taxation until the end of 16. But again, 17 we don't know. It's very similar in other countries. Norway, for example, has been the same, but I think that people have been more like they will still go for no taxation and so on. And I think even they will do it until 17, maybe you don't know this. I think in Norway there will be no taxation on cars for a longer period, all the way to 2017.
But they have 25% of all new cars are electric.
Yeah, huge amount. That's not the case in Denmark, unfortunately. Another good frame condition we have is that we actually get 50% discount on the grid connection. I think that might be a little bit special for Denmark. You pay really a flat fee per amp. So if you want to connect 100 amp, it's 1,000 Danish kroner per amp. And 200 amp is just double. But there's a 50% discount on that payment for connection. So that's a good stuff. The other thing is that when Clever and Eon, they're selling the energy to their customers, then they're actually allowed to give them a discount in the range of 40% because they get this back from the government because it's green energy for electric vehicles which are controlled by an EV infrastructure owner, and then they can get a discount on the energy. But if I'm just buying an EV and put it in my socket back home, and I call somebody and say I want a discount, then I'm not going to get it. So you have to buy your energy through the certified operator to get the discount. I think they did a good lobby on that one. The final thing I'm mentioning here is that you actually can apply for some discount on the car. It's 20,000 Danish kroner. If you have a company car which runs on diesel and you replace it by an electric vehicle, then you will get a discount paid by the company. So these things are very important, and I'm sure that you would need similar frame conditions on Iceland, even though your energy is very, very cheap, I guess. Cheaper than in Denmark, or much cheaper. So, now, how many cars do we have? This is some statistics from this association, the Danske Hraðhleðslu Alliance, who's doing this. They have much more if you search their webpage. But of course, everybody wants to know how many cars are there. And in general, by the end of 2014, we had 3,000 electric vehicles. This was only, I think, 50% of what we expected if we go 2-3 years back. So we are not following the expectations in general, but still there's a good growth rate, as you see. So, but we are some years behind what we expect. So the front runner is Nissan with Nissan Leaf, and obviously there are two reasons for that. They were the first to have a good car in the market, but also they have made a very good deal with the leasing company. That first actually bought, I think it was a few hundred cars, and then in the second step they took 300, also had 500, and now just in 2015 again they actually bought, I think it's 400 or 500 more, so the numbers are even quite much larger. So a lot of people are still doing leasing on an electric vehicle in Denmark, which is very popular and cheap, very cheap. The cheapest way to have a car actually. Then there's Renault Zoe, number 2, and the fantastic car of Tesla is actually number 3. This is a bit strange because of course it's a very expensive car, but due to the taxation, then if you want to buy an expensive BMW or Mercedes or whatever, then everybody buys a Tesla. It's you get much better, much more interesting car So the sales figures for BMW, Audi, and Mercedes for their 1 million Danish kroner cars are near zero for 2 years in Denmark. Everybody's buying Tesla. Volkswagen, BMW, yeah, they just got started. So I guess they only started in 2014. BMW really only in 2015 started getting some numbers. So yeah, not so many cars. We should have many more, because how many cars do we have in the Netherlands, for example? How many do we have in Norway? It's like 10 times more. Not in the Netherlands maybe, but it's really.
Yeah, in the Netherlands we have much more plug-in hybrids.
Yeah, we don't have that.
That's it. So what you see in a lot of countries, the taxation has a very important. The taxation has a very important effect on how many cars are sold. And Norway is so that the taxation advantages are only for battery electric vehicles. So they have a huge amount of battery electric vehicles. Now I heard that 25% of every new car which is being sold is battery electric vehicle, and almost zero plug-in hybrids. In Holland it's the other way around. Very many plug-in hybrids, but not so many battery electric vehicles. But in Holland now they will reduce the tax advantages for plug-in hybrids, because they find out that many people who drive a plug-in hybrid are not driving a lot on electricity. They just take the car of all the tax advantages and not plugging it in. So in Holland, you will see now that the tax advantages for plug-in hybrids will go down rapidly, and the battery electric vehicles will keep it.
Yeah.
But I said, if you look to the near future, a lot of very nice battery electric vehicles are coming with good ranges. So I believe absolutely that what Jonas is explaining.
I think we hope to go to a figure like 10% of all new vehicles sold is an electric car. And this would mean, I think, around 6,000 cars per year. I think we have in total like 60,000 cars sold per year. We are not that close to that number, but hopefully in a few years' time we will. So, some words about Clever and Eon, because they're really the ones telling the story. We basically just supply the fast charger. So we started out with Clever, and as mentioned, they really rolled out the first country nation fast charging network, and it was finished doing that by 2013. They put out 50 fast chargers of the ABB type Terra 51. Which at that time only, that's the one you see here and here, was only able to do CHAdeMO. So it's only a CHAdeMO fast charging. This is an ABB car can do fast charging with Mitsubishi IMU. And yeah, you really see that this is the countrywide network. So they're all over. And even on our new charger, we can even charge a Tesla with 2 plugs, not at the same time, but we can actually do it with either AC or this CHAdeMO charger. Here we have a Tesla charging on our new charger today. And I think that we can say that we have actually sold more than 150 chargers for Clever in Denmark. One of the reasons is that all these Terra 51s that you see that can only do CHAdeMO, they're actually right now being replaced by new ones. So they simply just take them away and store them in a warehouse and hope to being able to use them something, because they cannot have a fast charging network where they can only serve CHAdeMO cars, because they need to be able to serve all kinds of chargers. So some of the chargers they have even bought twice. So Clever, they say about themselves that they are Scandinavia's largest electromobility operator, and in fact I believe that that's true. They have huge operations in Denmark, which you will see on the coming slides. And recently they actually also started in Sweden. So they have their headquarters in Copenhagen, but they have now started operations also in Sweden, and I believe that they will have during this year already 35 fast chargers installed in the Swedish market. They are quite large.
Is Clever a profit-oriented company, or is it operating to expand the electric vehicles usage?
So Clever is owned by a number of Danish utilities. So I think at the beginning 3 utilities, they went together and invested, and now more has come on board. And Clever is not so far doing fantastic figures on the bottom line, but they are there to earn money at the end. But it's really a long-term investment by utilities and it's really, I mean, it's all about locations. If you invest in all the right locations, you will be able to make money in 3 or 5 years' time. I don't know. I don't know the business case behind it, but it's not day one. That's for sure. I think if we go one back here, then it's not on this slide, but they have a strategy to expand out of Denmark to Scandinavia and further out of Scandinavia to Europe. That's what they want to do. Basically, they made a certain way of doing their operations, which they were the first one to do. They have a lot of experience, so they can transfer this knowledge to other countries, of course. And they will do partnerships with somebody in Germany or somebody in Norway. They can do it in Iceland as well.
What about the other companies and utility owned as well?
Yes, the competitor to Clever in Denmark, that is E.ON, so they are just themselves as a utility. But E.ON is one of the world's largest utilities operating almost worldwide.
So that's profit oriented.
Yeah, you could say. But again, it's also an investment for them. For sure. Yeah. So here is the roadmap of Clever. Actually, in the beginning, they were called TuneCV. So they were really doing, development for electric vehicles. They took a standard small car and took out the combustion engine and put in batteries and then tested it and sold it. They of course got a lot of government money and so on. And then here in 2011, they really started to be more commercial. This is another picture of the first fast charging station that we delivered. In the beginning, it was gray, and then they made it green. And here you see that they're really expanding out of Denmark to Sweden, and they also are going for partnerships with big brands like gasoline stations, companies like that, and of course automobile manufacturers. So this is how the full network of Clever looks today. So they have expanded into Sweden, and here you see what their plans are. So this is how it will look by the end of 2015 for Clever. They really have a huge number of stations, and as they say here, they already have 350, and they expect to have more than 500 in the operations by the end of this year. And I also mentioned earlier that what is their strategy? This is really to be where people go on a daily basis and make a stop by 20 minutes or 1 hour or 2 hours. So they are at these shops where you buy your food. They are at shopping malls, hotels, and so on. And that's their main strategy for fast charging. That's where they put up the fast chargers. But of course, they're also putting up AC chargers full public, where people have longer stops. This can be at the golf course, or of course this can be at people's work and so on. So that's mainly their strategy to do that. The products that they have is from the very simple AC charge box, which is offline, not connected. Then you can have again quite simple AC charger, which is actually connected, so controlled and communicated by Clever. And there are public and say also semi-public chargers, which are of course connected, and they can do up to 22 kilowatt. And then if you want to have real fast charging, DC fast charging, then it's the ABB product that they are promoted, and only that one. And people has to pay, and they can do that in 4 ways. So you can buy different memberships, where you basically say, okay, on a monthly basis I pay standard fee, and then I get, if I pay a high standard fee, then I get a low electricity price, and I get even, I can for example select charger 1, 2, and 3, which is close to me, and I have even lower rates on those chargers if I use them often. So you can have, say when you have your mobile, how do you want your mobile to get paid and be operated? You can choose many different ways. It's actually the same for the electric e-mobility. You can also just download an app, and then if you choose to go and plug in your car, then there's a button where you say, okay, I want to use my app, and then you just push the app and say, I want to charge this, charge by this charger, and then you get a bill through your on the telephone bill. So everybody can do that. You can also have a prepaid card where you say, okay, I just put 300 kroner on the card, and you can charge until the money is left. And then for companies and fleets, vehicles, you can have special cards that people can share and stuff like that. So there are many ways that they can actually get paid for their services. So, E.ON, in many ways they're similar, but they also have a little bit different mindset about mobility and infrastructure. So first of all, E.ON is a huge utility company. So you see here they have operations in more or less all Europe, so they are already, as you can say, all over. But where have they started? They actually started in Denmark. So that's the only country where they really have an operation running. But they do have also some things running in other countries, but not a lot today. So you can say the main office of E.ON and e-mobility is actually in Copenhagen. And this is where they started. And one of the reasons is that they had the chance to purchase this infrastructure already existing from Better Place, quite cheap also. It was a good deal. And this picture here is the first fast charger from ABB, which was commissioned on a highway station in December last year. And you see here their products, and again quite similar to what Peter was providing, not so much in different sections. Let's talk about a little bit about strategy and some thoughts, and I guess many people has thought about this. So they say that 90% of all Danish drivers they drive less than 80 kilometers per day, and I think if you talk about Iceland, it's even a lower number. So you would normally go maybe below 30 or 40 kilometers, so which would be somehow perfect for an electric vehicle. They also say that normally the car is actually parked up to 22 hours per day, so you don't actually drive the car that much. So that's again perfect condition somehow for an electric vehicle. And then what do they want to do? First of all, they say we need to have sufficient volume on DC fast charging because it makes people safe on the road. They always know that if somehow they forget to charge or they have to take a different route because whatever, go and pick up the children or something like that, then they can always find a fast charger. So that's one thing. And then they also say they need to put them also on highway locations where they actually started, because you need to be able to go from Copenhagen and across Denmark in an electric vehicle. That's simply a service that is needed. You can argue if you need to have the same in Iceland, you really need to be able to go around Iceland in one day and then make, I don't know, 8 stops to do fast charging. Maybe not. But that's the strategy for Denmark. Then they will also put up fast charging, they call it quick charging. It's the same as what we say fast charging. In the larger cities, of course, that's where all the cars are. And that's a little bit their philosophy. So this is the grid that they have, and actually, in Denmark, you can argue that this is even larger than Clever's. They actually have more than 700 full public AC chargers, and more than 500 which are not full public but owned by companies that use them. They have very little private, and here is where Clever have much more business compared to here. And when we look at fast charging, today they only have 13 inaugurations, which is on the highway. That's actually the white spots here. But they also say that by the end of 2015, they will have additional 30 of those fast chargers installed, mainly along the highway, but also in larger cities. So that's where we have a business with them today. And this is this is Denmark, and this is the Eon map of fast chargers on the highway. So basically, the first thing they did was that we were able to go from Copenhagen here and this way through the bridges to Aarhus. So this is the most, the highly traffic, where all the traffic are on the highway in Denmark. So we need to go that way. And now they're doing phase 2, where they put additional chargers up in other highway locations. And if you go and see their plans for 2016, which I've seen but cannot tell you, then there will be even more chargers on the highway and in big cities. So I believe that they will even double the numbers in 2016. So basically, I think that we can say we have, by the end of 2015, more than 100 fast chargers in Denmark, and we have less than 5,000 electric vehicles. That is really quite fantastic. I'm of course very happy that somebody has invested. But that's really the key word. I think that if you need a good development of electric vehicles and mobility on Iceland, somebody has to invest, and it has to be done somehow in an organized way, because otherwise it will be difficult to have the right service for people and the security that the grid will actually work, and wherever you go you can be sure to charge. So that's a little bit the story about Denmark that we wanted to share with you. I think our time is up. If you have any questions, of course, feel free to speak.
What about the network grid? Did you need to prepare it in some way?
No.
You just put down the charging stations and the grid was...
Yeah, I think that in Denmark we have quite a strong grid. I mean, the whole infrastructure is prepared for the future grid, and also our production of energy through all our wind power is so large that sometimes we even have to send money along our power to Germany or Norway. We have to have an overproduction that we cannot use ourselves. So we really just want more electric consumptions, electric vehicles, everything that can be electric. This makes sense for us. As it's, of course, also here in Iceland, because you also have a lot of energy that you can produce. So we don't have a problem with this. Of course, locally, if you have a road where people live, there are 30 houses, and all 30 houses, they have a Tesla, and they all start the Tesla charging with 10 or 20 kilowatt at 6 o'clock, then there's a problem, and that is really a problem. And I think you can point out maybe 10 spots in Denmark where there has been an issue where the utility needs to operate, but it's really nothing. That's what they have. So it's not a concern, not at all.
Þá er þessu lokið hérna núna fyrir hádegi. Kæra þakkir fyrir komuna.